So far on today's project, we've milled our stock, shaped it into a ring blank, and made our first joint. Examine it front and back to be sure it's right. Then we begin to blend the inside seam first. Using a half-round file, a few strokes should even out the inside of a well-fitted joint. Now we can move to the outer surfaces. A barrette file is used to smooth and blend the outside of the shank and sides, leaving a slight indication of the seam so we can locate it again a little later. Next, the ring blank is pounded round, smoothly conforming to the mandrel all the way around. When working with milled metal, I like to knock off all the surfaces with a fine-cut needle file, just to ensure smoothness and polishability. Now here is the gem we will be setting into our ring. It's an Australian boulder opal. Not a doublet, but similar in that it has a hard layer of the rock in which it formed, acting as a foundation on the bottom side of the stone. This adds a lot of durability to a typically soft gemstone such as opal. Since the gem is to be worn on a ring, where it will take much more abuse than a pendant or earring, a bezel setting will be sturdier and offer more protection than prongs. Here is the same stock we used to form the blank. Now we'll shape it into a bezel using double round chain nose pliers. We bend our stock to the contours of the stone's circumference, remembering to keep a sense of orientation with an asymmetrical gemstone. I usually eyeball the mark for the first cut. This way I can trim and fit the seam a couple of times to pull it down to an absolutely perfect fit before closing the joint. The stone should rest on top of the bezel with about 3/4 of a millimeter of metal visible all the way around. Just as with the ring blank, before heating this joint we coat it with a slurry of boric acid and denatured alcohol. Igniting this mixture deposits the boric acid as a coating on the piece, which protects the non-gold metals in the alloy from oxidizing when heated. The flux forms a film on the metal which helps the molten solder to flow smoothly and evenly. An important note is that every joint we make here uses 14 karat yellow hard solder. We want a good strong bond, and no lesser flow points are needed unless there is a much more intricate pattern of attachments.
Now we've made the major components. When we return, we'll assemble our creation. So stick around.